Welcome to adding lecture of graph function, and today we will do inverse of a function. In previous class we have done what? We have done types of function. There are four types of function. 1 1 on to first, 1 1 many one, 1 1 1 1 on to, 1 1 into, many one into, and many one on to. Now see, among these persons, suppose I have taken this function 1 to A, 2 to B, 3 to C, and likewise 1 to A, 2 to B, 3 to C, and D. Likewise you can say 1 2 3 A B. I have done these four, and 1 2 3 A B C. I have done these four. This is what? This is 1 1 on to, this is 1 1 into, this is many one on to, and this is many one into. Now, when we take in reverse order, from B to A, is it a function from B to A? Yes, it is a function from B to A. It is a function from A to B and from B to A also. Means we can write this as A1, B2, C3. Is it a function from B to A? A, B, C, D, 1, 2, 3. No, this is not a function because the D does not follow each and unique property. Likewise, when you go from there, say A, B, this is not a function. 1 many is not a function. And likewise, when you come here from B to A, this is again not a function. What are two basic criteria for function? Two basic criteria for function are what? Each and every element must correspond to each and every element must correspond to what? But correspond to F, unique element. Okay? Clear? Term unique. This is unique. A, make distinction between unique and distinct. A belongs to A, unique. 2 belongs to A, unique, but they are not distinct. Both 1 and B belong to same one. This is a function, but this one is not a function. So if A to B is, now come to our inverse of a function. If A to B is 1 1 onto function, then there also exists a function from B to A. So that function is called inverse of this function. That function is called inverse of this function. And with the same, you can say inverse of a function exists only when function is 1 1 onto, or in other cases it will not exist, as you have said. B to A, this is actually your BA, not function, BA, not function, BA, not function, and BA, function. So now come to definition. This is a basic point. Inverse of a function. Now come to this. Come to definition. What is definition? If A to B is 1 1 onto function, then there exists, or there also you can also write, there also exists a function GB to A. Z is called inverse of F. This G is called inverse of F, and commonly denoted by, and G is commonly denoted by F inverse. In fact, F and G are called inverse of each other. Though I am giving the express that this G is inverse of F, but both are inverse of each other. Both are what? Both are inverse of each other. So this is the definition. This is the definition of what? Inverse function. What does invertible function means? A function whose inverse exists. A function whose inverse exists is called an invertible function. An invertible function. Invertible function. It is always 1 1 on 2. It is always 1 1 on 2. It is also called bijective. Bi means 2. Bi means 2. Means both injective, means 1 1 and subjective means on 2. So what is the difference between inverse of an invertible function? A function whose inverse exists is called invertible function, and we will now learn how to find inverse of an invertible function. So this you have to note. Can you say difference between f and fx? Very simple point, but let me clear once. Actually, when I write fx is equal to x square plus x plus 1, this is a function f. And this function I am expressing in what? Actually, this is function f. I am expressing this in terms of what x? We can express this in terms of t square plus t plus, we can express this in terms of function u. So when we say there is a function f, it means we are not actually saying what is the variable. We are not actually saying what is the variable. But instead when we say function fx, means function is f, its variable is x. When we say function ft, means function is f and this is t. So many times you will see, and I also write function f, not complete. Normally we take x as variable, independent y as dependent. No, note the point. Now come to example. I am just erasing this one. Okay. So f is function. X is variable or function. In complete sense, this is called fx. Invertible bijective. Now see. Take example. Suppose there is a function. Suppose that this is 1, 5. Actually, I am taking a function. Suppose this is fx is equal to 1, 5, 2x plus 3. Okay? 2, 7, 3, 9. A to b function. 1, 1 on 2. We can also write a function. 5, 7, 9. 5 corresponds to 1. 7 to 2 and 9 to 3. This is a function from B to A. This function is actually your function f, and this is your function what? G. Can you say what is gx? You can guess what is gx. Yes, you can guess. But let me know. Let me say how we find. Mathematically inverse of a function. How do you find mathematically inverse of a function? Let me say. Actually, how do you find gx? I will write gx here. You can guess that it will be x minus 3 by 2. How x minus 3 by 2? Put x is equal to 5. 5 minus 3 by 2 is 1. Put x is equal to 7. 7 minus 3 by 2 is 2. Put x is equal to 9. 9 minus 3 means 6. 6 by 2 is 3. And this is actually denoted by what? F inverse. Just to do so inverse, actually this G is denoted by what? Normally this G is denoted by what? F inverse means inverse of F. But how to find it mathematically? That we have to learn. That the first point we have to learn. Or second point we have to learn. What we learn the first point? A function is called invertible function if it is 1 1 on 2 and we have to write from b to a. Now, how to find inverse of a given function? I just commit by guess, but now how to find inverse of a given bijective function? Bijective means what? 1 1 on 2 function. Now, actually, working rule. This type of rule we have done in bench. Let y is equal to fx and express x in terms of y. Express x in terms of what? Express x in terms of y. So now I am taking this one. Invertible function. 1 1. For example, let gx is equal to y. Let fx is equal to y. I am doing for this. Fx is equal to y is equal to what? 2x plus 3. What is the working rule? Express x in terms of y. Express x in terms of y. This is important. Express x in terms of y. So what do we do? This is y minus 3 is equal to 2x. This is y minus 3y2 is equal to x. This is y minus 3y2 is equal to x. Actually, this is your f inverse. This is your f inverse. It comes in terms of y. So we can say this as what? F inverse y. And what its corresponding? F inverse y is what? Y minus 3y2. So when we replace y by x, when we replace y by x, this is what? F inverse x. X minus 3y2. Actually, if we take here t, suppose we take here t, this comes in f inverse t. If we take here u, this comes in f inverse u. So this is again, when we find inverse function, it comes in terms of what? It comes in terms of y, and finally we replace y by x. This is what? This is our gx. So, before moving to next point, let me do one question, one very straightforward, very simple question. Let me do very simple question before moving to the next point. Now, let me erase this one. Easy. The question is, you can say find the inverse of fx is equal to, you can say 10 to the power minus x minus 10 to the power x upon 10 to the power minus x plus 10 to the power x. Find the inverse of this. Means what we have to do? We have to actually express x in terms of what? We have to actually express x in terms of what? We have to express actually x in terms of y. What we do? You see the process? Simple process. Let y is equal to 10 to the power minus x minus 10 to the power x upon 10 to the power minus x plus 10 to the power x. Now, how to express x in terms of y? For simplicity, we will multiply both by 10 to the power x. For simplicity. That you can do on your common sense. Then what is y? Actually, you can say y 1 minus 10 to the power 2x upon 1 plus 10 to the power 2x. Now look simpler. Here x occurs at 4 point. Now at 2 point. Multiply this by this by this, this by this and this by this. You will do this. Change side. Y plus y into 10 to the power 2x. Multiply complete by this. So what do we get? Y into 1y into this. What? This is 1 minus 10 to the power 2x. What do we have to do? We have to express x in terms of what? Y. So put these two together. This is y into 10 to the power x plus 10 to the power 2x plus 10 to the power 2x. 1 minus y. Now take 10 to the power 2x common. Y plus 1, it is what? 1 minus y, or 10 to the power 2x what? 1 minus y by y plus 1. It looks better. 1 plus y, right? This is. So what is? Actually we take log. Then 2x is equal to what? Log base 10. 1 minus y by 1 plus y. Actually you know, a to the power x to the power n implies y. Log n to base a is equal to x. That's what I have done here. So what is x? 1 by 2 log base 10. 1 minus y by 1 plus y. 1 minus y by 1 plus y. So x is expressed in terms of y. X is expressed in terms of what? X is expressed in terms of y. So this is our actually f inverse y. This is our what? F inverse y. It comes in terms of y. And we write final answer in terms of what? We write final answer in terms of x. Therefore, what is f inverse x? Therefore, what is f inverse x? What is f inverse x? F inverse x is actually our 1 by 2 log 1 minus x by 1 plus x. This is the answer of this question. But there are some if and but in the question. Let me come to the next question. Suppose how I take this question. Question number 2. Suppose f from you can say what is the graph of this? This is I am framing the question. Why I am framing the question? X into x minus 2 at x is equal to 1. This is what? At x is equal to 1. This is you can say 1. So suppose f1 to infinity. And this is you can say 1 by 10 to infinity defined by fx is equal to 10x minus 2. 10x minus 2. Find f inverse x. Now, in previous question, I haven't given this type of condition. But in this question, I have given the condition. Why have I given the condition? I will explain later. Let me start solution, but there is a very important role of this one. In this very question. Let me say. Now, first of all, let me do the solution. What is this? This is y is equal to 10x minus 2. What is log y base 10? X into x minus 2, we take log straightforward. You can recall the definition of log a to the power x is equal to 1. Log n base a is equal to x. Now, we have to do what? We have to express x in terms of what? We have to actually express x in terms of y. So what do? We will make a quadratic equation. X square minus 2x. Change the sign. Minus log y 10. 0. So what is x? X is actually b plus minus. Minus b means to plus minus. B square 4 minus 4 into 1 into this minus will do this plus. Log y base 10 divided by what? Divided by you can say 2. Take this common. What is this? This is actually 2 plus minus 4. 1 plus log y base 10 divided 4 root over. This is actually 4 root over, and when it comes out, this is what? This is 2 by 2. This is what? 1 plus minus 1 plus log y base. Now, If it is given that function goes from R to R, if it is given that function goes from R to R, this is not a function, because for one value we cannot get two inverse function. For one particular value we cannot get two inverse function. So what we have to do? Now we have to see here. Now we have to. This is what? This is values of x. So since x greater than equal to 1, see the domain, since x greater than equal to 1, what do we consider? We consider x is equal to 1 plus log y base 10 for the given domain. For the given domain. If in this question domain is from minus raised to 1, if in this question domain is from minus raised to 1, suppose this is the domain, what do we do? Suppose this is domain, what do we do? This is less than 1, in this case we consider what? Minus. X greater than 1, 1 plus something, x less than 1, if given, minus something. That we have to justify. And if this is from R to R, 1x at those two values, this is not 1 function, so inverse does not exist. So this type of situation must be taken in care while doing the question of inverse function. This is your actually what? F inverse y. So what is F inverse x? What is F inverse x? Therefore what is F inverse x? This is your F inverse x. 1 plus 10 in terms of x, F inverse x. And what I am doing, why I am framing question, I am concentrating on this. Actually, I am concentrating on this. Now you can see what was my criteria there. Actually, this is from 0 to 2. This is graph of what? X into x minus 2. You can see this is what? This is many one function. I start from here. Start from where? 1. From here this is what? From here this is what? 1 to infinity, this is 1 function. And what is complete value at x is equal to 1? What is complete value? This is add x is equal to 1. This is minus 1. But what is its value? 10 to the power minus 1 is what? 1 by 10. So I have adjusted this data such that it must be 1 onto function. Otherwise what? Otherwise inverse does not exist. Now let's come to one more question. Simple question. Okay. I hope the question is find the condition so that fx is equal to x cube plus px square plus qx plus r is a bijective function or invertible or inverse exist. Find the condition so that, and where is f? I will get f goes from R to R. F goes from where? From R to R. If nothing is given, we normally consider the complete domain. This is a what? This is cubic polynomial R to R. No. See what we have to do. What we have to do now? Actually, we can see this must be 1 on 2. This must be what? This must be 1 on 2. Being cubic polynomial. Range is equal to what? Range is equal to R is equal to codomain. So it is always on 2. It is always on 2. There is no problem as far as what? As far as on 2 function is concerned. Now it must be 1 now. It should be 1 now. 1 for required condition y 1. What is f dash x? 3x square, differentiating that one, 2px plus q. It will be greater than equal to 0 for all x belongs to R if d less than equal to 0. What is the condition of a quadratic equation to be positive? The condition for a quadratic to be positive, a greater than 0, d less than equal to 0. Here this is a always greater than 0. Here this is a always greater than 0. What I am going to do? Actually I am finding the condition that it is always increasing. Means f dash x greater than equal to 0. Sir, why are you not going for decreasing? It cannot be always decreasing. It cannot be always decreasing because for this must be negative. Since this is positive, only possibility is what? Only possibility is what? This is increasing. And for this to be positive, what? For this to be positive what? This is f dash x. For this to be positive, this should be less than equal to 0. So what do we get? 4p square 4 into 3 into q less than equal to 0. 4 cancel. P square minus 3q less than equal to 0 means p square what? Less than equal to 3q. Find the condition for it, bisective, invertible. Okay, clear? For one function we have to prove what? We have to prove either it is entirely increasing or entirely decreasing. But here it cannot be entirely decreasing because for entirely decreasing what is the condition? F dash x less than 0, what is the condition? This is not graph of fx, do not confuse. This I am showing this is above x axis always positive, this I am showing below x axis always negative. So this is the condition. Now come to one more question of this type, then I will move to next property. These are common questions. Find the values of p so that fx is equal to you can say px plus sin x is possesses inverse. Possesses or you can say px plus I is invertible. Is random in what? Possesses inverse. Now, how we see? This is the same logic. This must be 1 1 on 2 function. This must be 1 1 on 2 function, same logic. And function goes from where? R to R. Nothing given. Take complete domain. F goes from R to R. When p not equal to 0, range is equal to what? I have done index when p not equal to 0. When p not equal to 0, it slides from minus infinity to infinity. If p is equal to 0, situation change. But this minus infinity to infinity, p not range R. So what do we do? What do we do now? We have to take again 1 1 function. For 1 1 function, what do we do? What is f dash x? Going for increasing, decreasing. P plus cos x. Now we consider both case. How both case? For increasing function, f dash x should be greater than equal to 0 means what? P plus cos x greater than equal to 0 means what? P greater than equal to minus cos x. Since the value of cos x lies from minus 1 to 1, so p must be greater than equal to 1. This lies from where? Minus 1 to 1, so p must be greater than equal to 1. For decreasing, here we can consider decreasing, entirely decreasing. F dash x less than equal to 0. From here we get what? P plus cos x less than equal to 0. From here we get what? P less than minus cos x. So this is less than equal to minus 1. And both do not contain p not equal to 0. Both not contain p equal to 0. So what is condition? Required condition p belongs to minus infinity to minus 1. You know what to infinity? In this interval, this is entirely increasing. So invertible. In this function, this is entirely decreasing. So invertible. And see one more. Suppose make this point. Make note of this point. Suppose 2 less than a less than equal to 5. Then b greater than a implies a greater than equal to 5. And b less than equal to a implies a less than equal to 2. Be careful about this. For greater than value, we will take greater than from the highest value, and for less than from the least value. That I have done there. This value lies between -1 to 1. So for greater than value, it must be greater than equal to the greatest one, which is 1. For less than value, it must be less than equal to the smallest one, which is what? -1. So is the case. Now, come to more points. First of all, come to geometrical property. Geometrical property of inverse function. Favorite area of IT. I am here writing 2 points. A, y is equal to fx and y is equal to f inverse x are image of each other with respect to point, with respect to line y is equal to x, or you can say symmetric to each other with respect to line y is equal to x. What does this mean? This is the first property. And second is just outcome of first. Second property is just what outcome of first. But let me do the first one. Suppose this is a function and this is its inverse. This is inverse. This is fx. You can take anyone as fx at this is actually symmetric to what? Line y is equal to x. Symmetric to what? Symmetric to line y is equal to x. Means this is mirror image of this. This is mirror image of this. Is this. You can consider one more case. Suppose make one more figure. This is actually for property 2. This is fx. This is what? F inverse x, and this is what? Y is equal to x. Why? I will explain, but before that let me write the second property. This is actually your first one. Graph of y is equal to fx and y is equal to f inverse x. Whenever intersect, they intersect along the line. Which line? Y is equal to x. Very obvious logic. If they are symmetric and they intersect, they always intersect on what? Y is equal to x. Very obvious logic. But there is one great conclusion from this. I am actually interested in that conclusion that I am going to write. The conclusion is that hence solution of f inverse x is equal to fx can be obtained by solving either fx is equal to x or f inverse x is equal to x. Favorite area of IT. Means since these three meet at one point, what we will do? Suppose we have to solve this and this. We will solve this and this. We get the point. We get the point. So image of each other y. Image of each other y. Very simple logic of coordinate geometry. I hope you have done in coordinate geometry. Now I am giving logic for this. Suppose do like this. Suppose this is, or let me erase that one. Let me erase that part. Let me erase that part. I need some place. I need some place. Suppose this is alpha, this is beta. I am going for explanation. I am going for what? Explanation of first one. And suppose this is beta and this is what? Alpha. This is our fx. This is what? Our f inverse x. This is our fx. This is what? Our f inverse x. This is the definition. This is alpha beta, beta alpha. Just I have done in beginning of the class. But we know from where? From coordinate geometry. We have done proof of this. From coordinate geometry that alpha, beta and beta alpha are image of each other with respect to line y is equal to alpha. That we have proved in coordinate geometry, and that we find in the definition of what? That we find in the definition of this. If fx contains alpha beta, then f inverse contains beta alpha. So if this is alpha beta, then this is what? This is beta alpha. If this is gamma delta, then this is what? Delta gamma. Every point, because here if there gamma delta, then what you get? Delta gamma. So every point of this function is image of y is equal to x on this. So is the explanation. Now let me do one question. That question was asked in IIT. And also given in my favorite book IIT. But now I am going to discuss. If you want to write something or note something, make pause and write. After that I will go for one more property. But let me write the question. The question is number 5. Let me write the question. This is from IIT. The question is where is the question? Where is the question? Let f 1 by 2 to infinity, 3 by 4 to infinity, where fx is equal to x square minus x plus 1. Find the inverse of f and hence or otherwise solve the equation. X square minus x plus 1 is equal to 1 by 2 plus root over x minus 3 by 4. Very important. Now, first of all, let us find inverse. How do we find inverse? Let y is equal to this. Change x in terms of y. For this, I will transfer to this. What is this? Minus b means plus 1 plus minus b square. 1 square minus 4 into 1 minus y by 2. Come here. X is equal to what? You can say x is equal to what? This is 1 plus minus, this is what? This is actually 4y is plus 4y minus 3. 4y minus 3 by 2. We will sense x greater than equal to 1 by 2. Now come here, I have just done 1 or 2 question before. We consider what? We consider x is equal to 1 plus. For plus we consider plus. For minus this is less than 1 by 2. This is actually what? 1 by 2 plus minus. Actually this is written 4y minus. So we will take what? We will take what? We will take plus. We will take x is equal to 1 by 2 plus 4y minus 3 by 4. And this is what? This is our f inverse y by 2. So what is f inverse x? F inverse x is 1 by 2 plus root over 4x minus 3 by 2. We can also write it as. When we put this 2 inside square root, this is what? 1 by 2 plus x minus what? 3 by 4. This is f inverse x. So answer the first part. Actually this is the correct answer. But why I come to here? See the second part. This and this are equivalent. See the second part. In second part, this is the main point of this geometrical property. This is fx and this is what? F inverse x. So now come to, if you want to write, pause and write. I am coming to second part. Actually, second part, we have to solve what? We have to solve x square minus x plus 1 is equal to what? 1 by 2 plus. This is what? Fx and this is what? F inverse x. So what I have written in second property? Since fx is equal to f inverse x, solution is also obtained by what? Fx is equal to x. Means what? X square minus x plus 1 is equal to x. Now things become easy. It's a very difficult to solve it. When you make it a square, this is a fourth degree. You have to go for trial. But now this is easy because actually this and this intersect at same point. Solve it. X square minus 2x plus 1 is equal to 0. X minus 1 is square 0. So x is equal to 1. You can verify x is equal to 1. So be careful. Whenever we have to solve fx is equal to f inverse x, it's easy to go with fx is equal to x. Now, let's come to another definition or property. Actually, we say property, but NCERT is definition. We say property, but NCERT said what? Definition. Let move, and this data will be required. Now, let me erase this one from this side. Property. Another definition according to NCERT, for me this is property of inverse function. If fx and gx are one on two, this is a condition, functions such that f gx is equal to gfx is equal to x. then f and g are called inverse of each other. Inverse of each other. Here y is equal to x is identity function. Identity function. It is also denoted by ix or ix. You may find in some book including in NCERT, this is written as ix or ix. This does for identity function y is equal to x. But I will go for this ix. Many authors write for identity function ix. But what is identity function? Y is equal to x. This I is written here just to emphasize. You have to keep in mind that finally we get was identity function. This is one of the definition of inverse function. Since GF inverse, therefore this is the property f inverse fx. This is the property is equal to x. Composition of a function with its in language. If you want to write, you can write composition of a function with its inverse. Composition of a function with its inverse gives what? Which gives identity function means x. This is the property. Now we will do previous question by this method now. We will do previous question. So though I have written the data. Now if you want to write something, you can write. You want to write, you can write. But before that, you can see a very simple example. E to the power x and ln x are inverse of each other. What is the basic logic? Each other. Because you can see e to the power ln x is equal to x and ln e to the power x is equal to x. What I have written? Have you get it? If fx e to the power x, gx what? ln x. Now see with this definition. What definition? F gx is equal to gfx. Suppose. What do we do? What is actually your f gx? What is your f gx? We can write f gx is what? ln x. What this is what? E to the power ln x. You know the formula. This is x. What is gfx? First of all, we will write what? First we will write g e to the power x. What is g? G is ln. So what? ln e to the power x. X ln e means what? X. Both are x. So inverse function. So whenever we prove these two are inverse of each other, this will be invertible. Now let me come to question number 6. I will do question number 5 with this very property. I will do question number 5 with this very property. Come to this one. Question number 6. Suppose f goes from where? Suppose f goes from 1/2 infinity to 3/4 infinity, defined by fx is equal to x square plus 1 and g, actually these changes 3/4 to infinity to 1/2 to infinity, defined by gx is equal to what? 1/2 plus x minus 3/4. Prove that f and g are inverse of each other. What is the process? We take this y, expense x in terms of y, but now I will do the above definition. You can also do, there is no need to do this. Y is equal to ln e to the power x is equal to ln y inverse x. You can do, but this time I will do with definition. I will go with definition. What I have proved in the question number 5, now I will go with what? I will go with definition. Now, let's see. What is this? Simple calculation. Fx is what? X square minus I start solution. And gx is what? 1 by 2 plus x minus 3 by 4. What is f of gx? F of gx, composite function. You have slight idea of this. First of all, we will write gx. What is gx? See f gx. What is gx? Actually, this is 1 by 2 plus x minus 3 by 4. Now, for x we will put what? Now, this is fx. For x we will put what? Instead of x, now what we get? 1 by 2 plus root over x minus 3 by 4. So, what we do? We will go for this. If x square minus x. Instead of x, we have now this. So, what will I do? 1 by 2 plus x minus 3 by 4 whole square. First of 1. Then minus 1 by 2 plus x minus 3 by 4. And what is finally? Finally, we get there 1. Now, simplify. This is 1 by 2. A square plus b square x minus 3 by 4 plus 2ab means 2 into 1 by 2 into root over x minus 3 by 4. This is minus 1 by 2. This is minus x minus 3 by 4 plus 1. This 2 and 2 cancel each other. Now you can see these two also cancel. So what we get? We are still working on what? We are still working on f gx. What we get? Actually we get 1 by 2 plus x minus 3 by 4 minus 1 by 2 and finally what? Finally we get what? Finally get no. I am doing mistake. Let me correct. Actually this is 1 by 4. This is a square. A square plus b square plus 2. This is what? This is 1 by 4. Now. So 1 by 4. This is x minus 3 by 4. These two terms cancel. This is minus 1 by 2. This is finally what? This is finally your plus 1. Now you can see these two are what? 5 by 4 and these two are what? Minus 5 by 4. So cancel x. Identity function. Identity. NCERT write this by ix. I am not using, but I will write x only. Now come to gfx. For this g, first of all we will put what? This is what? X square minus x plus 1. So 1 by 2 plus. What we will write? For x we will write what? For x we will write this one. For x this time we will write this one. X square minus x plus 1 plus 1. Plus or minus? Is it plus? This is minus 3 by 4. No. Let's see. What is this? This is 1 by 2 plus x square minus x plus 1 by 4. And you can guess easily that this is x 1 whole square root over. And this is what? 1 by 2 plus x minus 1 by 2. So, since both f gx and g of x are identity function means x. Hence fx and gx are. Hence fx and gx are inverse of each other. So let me come to one more question. So the question is actually this is a logical question from previous IIT, and IIT vacation I will discuss. This type of question can come though less chance, but very interesting one. The question is that interesting one. let f from domain xyz, discrete element, to range or codomain, what you say, be 1 function. Actually this is codomain, but in this case this is also range. Then find the function f. This is actually complete logic. This is actually what? This is actually complete logic. Actually function is 1 means 1 corresponding to 1, so it is also on 2, but we have to concentrate on this. Only one of the condition is 2. Only one of the condition is 2. Means what? We take case 1. Suppose fx not equal to b is true, fy is equal to b and fz not equal to a are false. This is the condition, true and false. This is true and both are false. So what is the possibility? We will work on possibility. This is x, y, z and this is a, b, c. If fx not is equal to b is true, means x either goes to a, or what is the possibility? Either goes to c. If this is not true, means what? What is true? Either x goes to a or x goes to what? B. Fz not equal to a, false. Fz not equal to a, false means what? Fz not equal to a, false means fz is equal to a is what? True. Fz is equal to a is true means what? Fz is equal to a is true, fz is equal to a is true. Here this is not 1. We know not 1. Still one condition is left, but here this is not 1. Now see, can we get y is equal to b from this condition? But here it is written that y is equal to b is also false, means y goes either to a or to c. If y goes to a, this is what? If y goes to a, this is again many one. If y goes to c, this is again what? Many one. Means from this we get what? Many one. Many one in both cases. Many one in each case. So what is the conclusion? What is the conclusion? When we take this as true and this true as false, we will not get 1 function. So we will not get 1 function. Now come to case 2. What we do in case 2? In this case, this time we let fy is equal to b is true and fx not equal to b and fz not equal to a are false. This is true. So can we get question from this? What is this? This is x, y, z, and this is what? This is a, b, c, x, y, z, and this is what? This is x, y, z, and this is a, b, c. What do we say? X goes to where? Fy is equal to b true, y goes to b is true. Fx not equal to b or false means what? X also goes to what? B. Fx not equal to b is false, means fx is equal to b is true. If we go from this, we get as many one. Now, where z goes to a or c or b doesn't matter, it is many one. So in this case we also not get any 1 function. What are the condition? Any one is true. What we have done? I have taken in first case this 2 both 2 false. In second case this 2 1 and 3 false. And I am moving for third case. If you want to write, you can write. I will erase this one. Make pause and write. I will erase this one. Case 3. Now case 3. Come to case 3. Come to case 3. This time I will take fz not equal to a is true, fx not equal to b and fy is equal to b are false. Now see, fz not equal to a is true. Again, as in case 1, it depicts it 2 ways. It can be It can be done in two ways, x, y, z. This is what A, B, C, and what is this? F z not equal to A students, z either goes to what? B, or z either goes to what? C. This one. Fx not equal to B, it false means what? This goes to B, this goes to B. This is minimum, not 1 1. This also ruled out. Now, Fy is equal to B false means Fy either goes to A or goes to what? C. When Fy goes to, when F means Y either goes to A or what? C. When Y goes to C, this is what? This will give minimum. This will give what? Minimum. So for 1 1 function, we must go Y to A. So we have to go for all the possibilities and finally we get 1 1 function. 1 1 function is, actually this is xa, yb and zc. In this type of question, you might not get answer, you might get more than one options. What do we have to do? We have to work for each possibility. If you get a possibility from case 1, you also go for case 2 and 3. You will have to go for all the possibilities. I am providing this type of question in which there is more than one answer, or you might not get any answer. It might be question of integer type. How many 1 1 functions are there following this condition when only one is true? So this is all about your inverse function or invertible function. I will take one more class. In that I will discuss some composite function and miscellaneous points from function. Okay? We will meet in next class. Thank you.